Howdy again, it's tubalcain, and this is Machine Shop Tips number 278, entitled Making a Center Drill Driver for the Atlas Lathe. Now, what is a center drill driver? You've seen this in one of my recent videos, and it's nothing more than a Morse taper with a hole in it, and this is specifically made to hold center drills. And normally we're doing it with a standard Jacobs chuck of whatever Morse taper size machine you're working on. And we hold our center drill this way, and center drilling is a very common operation. You're just doing it constantly, so it's much easier and more compact if you use a center drill driver to hold the center drill, and it can be dedicated for that purpose. Now, my favorite size of center drill is a number 4. That's this size here, and it's 5/16 diameter on the body and 1/8 inch diameter on the tip. So that's the one I use the most often, and evidently that's what Cleveland decided when they made this many years ago to accommodate a number 4. And this is a number 2 Morse taper made by the Cleveland company, and it's marked 5/16, and then there's a stock number on there, and it has a tang on it. I don't know if they make these anymore. I did a little bit of research and I could not find it. But it's not simply a holder. It not only is it split so that when you put it into the tailstock or the drill press, it compresses and holds the work, but it's also machined inside such that when you insert the center drill, and I showed this in the other video, and push it all the way in and then rotate it, you will feel it lock and click into position. Like that. I doubt if you can hear that, but it is locking into position. So now let's go over to the Atlas lathe and I'll show you the advantages of using this. But before I do that, in this video I'm going to show you how to anneal, to soften steel, so be sure and stick around for that. This is the tailstock of the 12-inch Atlas Craftsman lathe. Now look at how much more compact this driver is than the drill chuck, and how much less it extends out. Now sometimes that might be a minor nuisance, but when that goes in, you see how much shorter that it is. And that will be a big advantage for some, and possibly a disadvantage for others. But I like these. Years ago, long before I even knew that there was such a thing as a manufactured driver, I had made one myself. Now I just took an old drill bit that had number 2 Morse taper, and I cut it off and drilled it and put a set screw, and that's what we're going to do today, only in a larger size taper, a number 3 taper. But you can see how simple that really is, and that's what we're going to do today. But let me show you another thing. Again, I want to make it in a number 3. This particular product right here, whatever you want to call this, this is an end mill holder, and this was made for the Atlas lathe, and this goes in the headstock, which is a number 3 Morse taper, and it's held in with a drawbar. And the purpose of this actually is not to hold a center drill, but that certainly would work, and that's what I've been using it for. But the purpose was to hold an end mill so that you could use the milling attachment on an Atlas lathe. And it is not proper, or it is not workable to hold your end mill in a 3-jaw chuck. It will work its way out, whether it's the big chuck or a drill chuck. You need a holder like this. And this was badly damaged. This is brand new, but it was badly damaged by mouse urine over the years. And I showed that in one other video that I had. And then this little box here, which is chewed by mice, was a series of adapters that was used, they look like this, used to hold different size end mills in this device. But this could be used also as a driver. But let me show you the disadvantage of this, because there is no tang, and I want one with a tang, and you'll see why momentarily. And this is what it looks like on the Clausing Lathe, and you can see again how much shorter it is than a Jacobs chuck. But remember that a little flat has to be ground onto the center drill, and this held with a set screw in order to to hold the center drill in place and keep it from turning, whereas this device is self-holding. Now, a disadvantage to using this end mill adapter that I'm using, and it would work fine, but it is hard to get out. That is, I can back the tailstock out and it is not going to release because there's no tang on it. So in this case, in order to get it to release, it's a little bit awkward because I use this brass wedge, and of course then it comes right out. But I want to make mine with a tang, and then I won't have that problem. So what is your source for a Morse taper shank to make one of these? And I'm going to show you here, but some of you are going to be disappointed because I'm not going to turn a Morse taper on the lathe. Now, that may be a subject much later on down the line, but that is not all that easy to do, and it makes the project too laborious and long. So I'm going to sacrifice this old drill bit that's bad on the end by annealing it and cutting it off, and there's my number 3 Morse taper, the same as I did at one time with this number 2, and then I never did use it. Now, another source is to buy Jacob's Arbors, but these also are going to be hardened. At least most of them are hardened, and you cannot machine them, drill them, or do anything with them until you anneal them. So that's a problem. So here's what they call a blank Morse taper, but this one also is, well, this one is dead soft, and it is quite usable, and I did buy that for a project at one time, but this is the drawbar type that does not have a tang, but these are available with the tang also. So if you can find one for under $10, go ahead and get some of these, maybe get several of them for different jobs, but that's nicely machined and ready to go. This wouldn't even have to be turned down, although it would be a bit bulky to use. So this is my source, and now I'm going to go over to the little heat treating furnace, and we're going to anneal this. That means to soften it, to take the hardness away. To repeat myself, this is an annealing operation, and that will take the heat treat out and soften the metal to its original state. However, this is tool steel, and I had to give $4 for that so that I can cut it off. My little Johnson 2-burner furnace here, I believe, is making its debut, and this is actually a little heat treating furnace or soldering furnace, and it's lined with asbestos, so don't tell the EPA or OSHA or anybody on me. And I don't think this furnace was ever fired until the other day, but it's using natural gas, and this has a pilot light on. It's a lot nicer than the ones that I had at school. So it's ready to fire, and then I'm going to put this in just like that and let it heat up. It'll probably take about 15 minutes until this is cherry red. And at that point, I'm not going to do anything with it. I'm going to turn the burners off, and I'm going to let it cool as slowly as possible. And the whole idea with annealing is to let it cool slowly. Well, where's the best place to do that? And that is to leave it in the furnace, because the entire furnace is pretty darn hot by that time, and it will take several hours for it to cool down, or at least 1 hour. So let's turn that little beauty on and see what we got. Just about like that, and let's take another look at it in a few minutes. It's not quite there. I want it to be cherry red all the way through its thickness. So it needs to stay in there a little longer, and that's what we call soaking. Soaking means that it is getting to the cherry red color throughout its full diameter. And when we get there to that temperature, that is called the critical temperature, and that is in the area of right around 1500 degrees. And at the critical temperature, it also loses its magnetism, and many people do not know that. Okay, that's been about 10 minutes in all, and it is at the critical temperature. This is a magnet. Absolutely no magnetism there. Now I'm going to put it into the furnace and just leave it there. I'll even put a little cover on there to retain the heat, and it's going to stay in there for about an hour or so, whatever I decide, and then it can be cooled, but do not cool it in water now or you have negated the entire operation. This is the standard heat treating chart that is in virtually every book, and I'm sure you've seen one, and this is put out by the Temple company that makes those Temple sticks that I showed you in another video. But along the side here you can see the temperature in degrees Fahrenheit, and it starts turning just a little bit red right about at 1000 degrees, and it gets redder and redder, and up here in the zoom in just a little bit, 1500 degrees. There's a lot more information here than you need to know, but right about 1500 degrees here is the critical temperature. Matter of fact, it says there's the magnetic point there at 1400 degrees. So we do not really want it any hotter than that, and when you go higher and higher and higher, it turns yellow, and then eventually that's well, liquid at 2900 degrees. So we're not interested in that. We're interested in the red colors, cherry red in the center there. I have no other way of measuring that temperature here other than by eyeing it, and that is the time-tested method that blacksmiths and heat treaters used for hundreds of years, but now there are fancy instruments to do that, which I do not have, and you probably do not either. So but this is really easy. Just cherry red, bright red. Okay, it's the next day and the drill bit is long cooled and is annealed. So I have no good way of checking it, such as a Rockwell hardness checker, so I just use an old file and we'll see if it's soft. And I can easily file a groove in there, and now I'm ready to saw it off. But before I saw it off, I want to do one other operation, and that is to mill a flat on there, which I will use for the set screw hole. So just a little bit of a flat, because later on, if I cut it off first, there's just no good way to hold this in the milling machine. Now that could be ground as well, but I'm going to very quickly take it over to the milling machine and hold it by the flutes and put a little bit of a flat on there. The drill bit is set up in the milling machine here, holding it by the flutes, and let's see if it's soft enough to mill. Yes, indeed, it is dead soft. And that's good enough. I'm sawing it off with a hand hacksaw just in the event that I run into some hard spots, lest I destroy my bandsaw blade. So these are cheap blades. And I'll laboriously saw through that, and that could be done with probably on the lathe with a cut-off tool or on the lathe with the hand hacksaw, which is a little bit dangerous, but be sure and wear your glasses now at all times in the shop. There it is. I put in a brand new Starrett blade and it went right through. Paint from the new blade. And there's the flat. Now what I plan to do is to machine this right in the Atlas lathe because it has a number 3 spindle. So this will fit right into the spindle without using any adapters or any other nonsense that might bring error into the whole job, because I would like this hole to be nice and concentric. So the first thing I'll do is put it in the lathe and face this off. So let's step over to the Atlas Craftsman. I took a minor detour on the way to the Craftsman, and I stopped at the Clausing and I chucked up the work, and I think I failed to tell you that when you heat treat, it invariably puts a scale on the work. And I want to take that scale off or just brighten it up a little bit before I put it into the taper so that I know that it will run true. Nothing fancy, but polish it up just a little bit. And if your scale is too bad, you might have to file it lightly. Now let's face reality here. 10,000 people will watch this video, but only 2 will actually probably make a center drill driver. But there are many other operations that I'm showing you here in shop techniques that may be helpful to all of you armchair machinists and other people that just enjoy doing this this type of work in your shop. So I brighten that up, but you can see that there are still spots there from heating it, but that doesn't hurt a thing. So make sure you clean your number 3 spindle thoroughly, and you can oil that just a little bit if you want. Wipe that off and pop it in there and protect your spindle thread. So I'll put a thread protector on there. You know, if you ruin your threads on your lathe, you got to throw the lathe away. So now that's ready to face. I think I'll tap that ever so lightly with my lead hammer here if I can find it, or my brass drift. And that's going nowhere. Now I'll face the end with my carbide tool. That squares it up nicely and brings me down to the approximate dimension that I want, which is very uncritical. This diameter is not critical either, but I'm going to take a light cut across it, remove that trademark, and I hopefully have made that flat deep enough so I won't machine it off. I could turn the spindle speed way up, but I'm not in the mood for taking the time. The diameter of a number 4 center drill, as said before, is 5/16, so I need to ream it 5/16. Therefore I will center drill it. That's also a number 4. And then I'm going to use a 1/4 inch as a pilot drill, and then this is 1 size under 5/16, and then I will ream it 5/16. Now it's very important that we get that on center so that, again, it is concentric. And in order to do that, of course, I'm going to use a center drill, and I'm going to engage it very slowly so that it finds the center. And I do know that the offset on the tailstock here has been checked, and it is in good order. But if your offset isn't 0, you're going to have a problem. So come in real slowly. I've already drilled 19/64, inch and a 1/4 deep, and this is the 5/16 reamer, and I'm ready to go. So much for that. I blew the hole out. Countersunk it first, blew it out, put a center drill in there, and it's just in there. It's a nice fit. I'm not going to pull it out and cut myself. And I put an indicator on there, and I am within 1/1000 of an inch. I would like it to be 0, but you know, I would like a lot of things. But I'm very satisfied with it being within 1/1000th. I just looked at the footage, and I actually on the indicator was about 2 thousandths off. it wasn't 1,000, but some of that comes into that sloppy spindle, which you saw me indicate in one of the other videos, and the bearings are not good on that lathe. There's over 1,000 slop just by grabbing it and wiggling it. Anyway, I laid out the hole here, and that's going to be drilled for a 1024 set screw, so that's 5/32 tap drill size, and there's the 1024 tap. And you know, everything around the shop has become magnetized, and it's actually quite a nuisance, so I got to demagnetize things, but I'm using so many magnets now that it's coming back to haunt me, so I'm not going to show that, but I have to be careful to hold this in the vise by the cylindrical part here, not by the taper, because it's difficult to hold a taper. I failed to mention this a few minutes ago, but you simply must get these double-ended carbide holders. They're just wonderful, and I have them in both the A size and the B size. So get yourself some, and they're not cheap, but they don't cost any more than people waste on Starbucks each week. And I do emphasize waste. Now I know I'm preaching to the choir, but before I tapped this hole, and I drilled it 5/32, but then I counterbored it with a 3/16 so that I don't have to tap quite so much, and that again, that acts as a guide. And use a little fluid, and as soon as I tap that, I'll run the reamer through here again just by hand in order to take the burr out. Just one last thing to do before it's completed, and there needs to be a flat on the center drill to keep it from revolving. In other words, to lock it in place. It's not self-locking like this other one, the commercially made Cleveland one. So I'd like a flat, something like this, on the end mill here. Now that can be done several different ways. It can just be done with a Dremel, or it can be done on the corner of your grinding wheel. It's just not important at all, but that looks so unprofessional, but yet it works. So let me try another method here and see if I can grind a proper flat on the lathe using the Dumore. Thanks to the good folks at Dumore Corporation up in Racine, Wisconsin, I'm going to use this grinder that they gave me, and it's mounted here in a Dumore holder in the Allures. And I've never done this operation because remember that the work is not going to revolve, and I've got about 1¼ inch cutter in there. I'm just going to go back and forth like this in order to grind that flat. Now I've never done an operation like this, and it may be a failure, but let's give it a try. And this, I believe, is the inaugural event here, the debut of my Dumore grinder, and I've been doing a lot of debuting here today. Now there's no good way to feed it up and down, so I'm going to take one pass, and then I'll have to very carefully lower this a little bit in the Allures tool post, possibly using a feeler gauge to come down, but certainly the dimensions are not critical, and the width of the wheel here is going to be the width of the flat. Alright, let's see how this works. I'm just feeding them with the cross feed. By the way, I am wearing goggles here, and I protected the bed. Of the lathe. I've got a little bit of a rag down there to catch the grinding dust. All right, I believe that's satisfactory. I took a couple passes across it. I believe it would have worked a little better if I had taken the time to dress the wheel, because the wheel and the holder here is not quite in alignment. But I didn't want to take the time to do that, so good enough, because it's all I need here is a flat for the set screw. Line up the flat with the set screw, and I drilled the hole just the right depth so that this is bottomed out and will not get pushed back in any further. when I use it to center drill. Tighten this up nicely against the flat. Again, a number 3 Morse taper, a number 4 center drill, but you could make this for any size center drill that your little heart desires. This is the 12-inch Clausing lathe, and I made this specifically for this lathe. And remember that the Clausing lathes have a tang slot, so that has to be lined up with the tang slot in the tailstock. And that's ready to go. And now, just for the pure pleasure of it, I believe I'll drill a center hole. In some 1-inch aluminum. Ah, the sweet smell of success. That concludes this video on how to make a number 3 Morse taper center drill driver. I hope you liked it, and I hope you enjoyed the part on annealing if you've never seen that before. Tell your friends about this, and be sure and watch my hundreds of other videos. And this is tubalcain saying so long for now.